So welcome. This is a short webinar in the Ascendo Reliability Series on getting started with reliability engineering. And I welcome everybody into the session today, and the recording will be available hopefully later this afternoon in the Ascendo Reliability site. I have noticed a good number of names that I recognize. I know a good number of you have been to previous webinars, and a few of you I know from our professional lives. So I doubt that you're new to reliability engineering. I doubt that all of you are. Maybe a few of you are. The amount of information that we need to master is stunning when you think about it. And how do we help other people get going, and how do we continue our own professional development? Those are all bits and pieces as well. How do we get going, and how do we stay fresh with reliability engineering? So I'm going to address a number of those different things, knowing that we come to this from very different places. So let me move over to the presentation. And just to double check, I want to make sure my microphone's set up correctly, and just go ahead and use the chat window in the upper right there, or the question and answer piece. Let me know if I'm coming through. Sounds good. Thanks, Charles. Appreciate that. Sean, good to see you in. I'm glad that the login worked for you. Loud and clear. Great. Appreciate it. All right. So I had, in talking to lots of different people at conferences and in different places I've worked and teams I've worked with, I have found that there's no one way that people become a reliability engineer. What I have found is that it's not something we're born with and we're destined to do, but sometimes it feels like that. My personal story was that I was working in an R&D group, and we were working on a polymer system, and my boss walked in and said, "Hey, how long will this product last? We need to show that it will last at least 20 years with a very low failure rate." And I had no idea about accelerated testing. I hadn't even heard of the Arrhenius equation, rate equation. And so the idea was that the ability to cheat time essentially was my introduction to reliability engineering. But I think even prior to just the idea of accelerated testing was the business question of, well, how long will this last? Will it last long enough? That was the question that the management team was asking. And they were looking to me, having done a little bit of statistics and a bunch of experimental work on our products, to go answer that question. And so that's how I got introduced to it, and I found that it was really useful. I found that as I used the tools in reliability engineering, I had more and more success in my career, and the products I was working on tended to be more successful. So that really worked out well for me, and I kind of fell into reliability engineering. Now, I had the advantage of working in a group that provided a lot of training. I got to go to a number of conferences. I got to talk to really smart folks in the industry. Wayne Nelson was one of my first phone calls when I started trying to sort out how to do an accelerated life test, and he's been supportive ever since, and I still ask him questions on a regular basis, and rely on this larger community that we're in to continue to learn how to do reliability engineering. So getting started can have lots and lots of different routes and lots of different ways of it happening. The site Ascendo Reliability that I'm just getting started putting together, and there's about 100 people that have signed up with it already, is my intent to create a reliability engineering professional development hub. So like these webinars are going to be hosted there, and the recordings are there. And there's a couple of ebooks up there now. There's a bunch of other information. And we're in the works to create, I have three other authors or speakers, trainers, educators, I'm not sure what the right term is for them, that are working to put together courses to offer through Ascendo Reliability. Plenty of free stuff, and we're going to put in some other good material for you so that it become a useful site. Just let me know what you would like to see there, if that's of all interest to you. So, reliability engineering. Now, when I first got started, I really had no idea what it was. I didn't call it reliability engineering. My boss asked me, how long does this last? How long will this product survive? And I was just an engineer trying to answer a question. I think my title was manufacturing engineer at the time, and working in this factory and supporting the R&D groups. But reliability engineering has been around quite a while. And one of the definitions I really liked when I was kind of digging around a few months ago is when you press the button, it goes. It's about as simple a definition as you can get. And I've seen other definitions, and I asked those questions out on the LinkedIn groups a couple of times. And it generally means that it should just work. It generally means that when a customer expects the product to perform, that it does. And there's a bit of environment in there. We all know the formal definition that it's a function performs in an environment with certain probability over a certain duration. And that's our more formal engineering definition of that. But this, when you press the button, is closer to how customers and most of our management teams think of reliability. So a lot of what we do is try to answer that question. Now, if you ever worked with a quality team or a quality engineer or quality management team, they'll think that reliability is just a part of product quality. Whereas I often come back to them and say, well, reliability is quality over time. We do everything you do and beyond the first day. So it leads to some interesting discussions. I don't recommend it unless you're with some friends. But the idea is that there's a common perception that a product, once you purchase it and you put some investment into it, it should work so that you get the value back out of that product. In reliability engineering, to a large extent, is this collection of tools and techniques and capabilities that allow us to identify risks, to make estimates and predictions, to evaluate products' durability. We can help the team understand what they need to work on and help the management team know if it's ready or not. Is it going to last long enough? That's what we do. And it's a lot of fun. It's not the same as designing a product or designing a manufacturing line and seeing it start up for the first time. It's more that it starts up every day, or that the product gives you the green light every day. That's what we do. So it's superset, to my way of thinking about it, of product development or manufacturing engineering. It's the entire idea of products from concept all the way through retirement and decommissioning. We work with nearly every organization or every department within an organization. There's very few other job titles that get this breadth of span of scope, I should say, of what we do. So it's, to me, just the basic questions we get to answer and the impact that we have on products is well, I enjoy it. That's about all I can really say about it. And I hope you do too. Now, not everybody is a reliability engineer. When I was at Hewlett Packard, there were only a handful of people that put it on their business cards. There weren't that many of us. But I found hundreds and hundreds of other engineers and managers that cared about reliability. That in the way I called it was they didn't just give reliability lip service. They didn't just say, oh yeah, our products are reliable, without really understanding what it meant. They had the basic tools and techniques and skills to make really good decisions concerning the reliability of whatever project they were working on. Your organization probably has a lot of reliability minded people. You yourself might be one. You may not be formally a reliability engineer, yet you're interested in it. Now, there's plenty of material to learn and master. It really starts, though, is that you care about it, is that you want the product to last for as long as the customers are expecting it to last. That's, and then how do you make decisions that are going to impact that performance of the product? And this overlaps obviously into safety and to cost benefit analysis and all kinds of other aspects of what we do. Yet the fundamental piece of getting started with reliability engineering is understanding that the decisions you make and the decisions your team makes impact the performance of the product over time. And if that's all it really is in my mind, right? Now, as a reliability professional working in an organization, I look for the people that care about reliability and encourage them and help them make good decisions, provide them the information they need. If they need a better tool, then we pull out a paper and pencil or a whiteboard and work through it and teach them how to do it. Keep in mind that reliability doesn't occur in a product or a product line by being thrown over the fence to the reliability team. It's in the design. I think I mentioned earlier, I started my work in reliability as a manufacturing engineer. And my experience as a manufacturing engineer was that it's always the designer's fault. Now, some designers got it right. They could make products that we could manufacture. They made products that lasted a long time. And other design teams didn't. It might have been a cost reduction, or it might have been a time to market type priority. Yet there's are folks out there that truly care about reliability and just need a little bit of support. And so that's where we find ourselves as we get started in reliability. Is you might be just tagged. Your boss might walk up like he did me and said, "Here, you're the reliability guy now." Or it might be just, "How long will this last?" It might be some other prompt or question. Or there are people that are already thinking about the importance of product reliability and go to school for it. We'll talk some more about that a little bit later. But eventually we become recognized as a reliability professional. We're invited to meetings, we're invited to reviews, we're asked the questions over and over again of how long will it last, what's going to fail, when will it fail, what will fail, how do we troubleshoot this, root cause analysis, all of those various tools that we deal with. And it becomes our role to let the team answer those questions in a very efficient way. And to a large extent, we roll up our sleeves and go answer those questions. There's professional organizations from ASQ and Society of Reliability Engineers. The IEEE has a group. There's Society of Maintenance and Reliability Professionals. I've drawn a blank on. There's a CRMP and SMRP, and I get the two confused. Which one's the certificate and which one's the organization? But there's and then there's various roles of reliability professionals within various disciplines. So, for example, just electronics. There's IPC has a lot of work on the quality and reliability of the circuit boards and their designs. But I think the professional part really relies on us. Okay, thanks, Orville. This certification of maintenance and reliability professionals. That's what it is. So the slides aren't appearing? What am I doing wrong here? So you should be seeing a reliability professional slide with a guy with a fuzzy hat on. You're seeing the slide, seeing it. All right. Okay. So hopefully it's working for everybody. It should be synced for everybody to see it. So hopefully that's working. All right. And it might be a little bit of lag coming back from it, but hopefully it'll work out for everybody. All right. Thanks, everybody. Uh, so that's just a little bit of an intro of what it is we do and how do we do it. But my main point is that it doesn't really matter if you have reliability engineering on your business card. It's more the attitude or the culture or the way we make decisions that makes us reliability professionals. And you could be a lead electrical engineer or you could be a maintenance planner. But if you're working through thinking about how long it'll last and what will fail, then it'll be a, a bit, it's part of making decisions that lead to reliable products. And that's what a reliability professional is really about. Um, and some of us come to it though with the title and formal training on it. We'll talk about that a little bit later. So Paula, I'm seeing the question downloading the presentation. So let me pull up the presentation, and I know there's a lot more people signed in just after we did the first intro. Let me bring up the opening um, window again. So on the right, let me bring up my handy dandy green arrow here. Just to the right of where the green arrow is, at least on my screen, there's a downloads pod. And in there you can highlight the slides or the webinar notes, and you can then download those files. And I'll leave this here for a moment. And while I'm here, I should also mention that in the presentation, if you're not too terribly concerned about what's going on in the chat window or the other pieces of this, is if you take your mouse and go near the top of the presentation window, or I think any of these pods, you'll see an expansion button that allow to take that particular window to full screen. It's pretty handy. And once it goes out there, I think you click it again inside the window and it'll compress it back to where it was. But there's a handful of different tools and techniques that you as a presenter have to control your own screen. So hopefully that becomes useful for you. All right, I'm going to bring up the downloads again near the end of the presentation so you'll have another chance for it. And if it still doesn't work, Paula, I'll have it as a link on the Ascendo site when I get the recordings posted. So hopefully that'll work out for you. All right. So one other thought here is well, what does it take to be a good reliability engineer or a reliability professional? Now, there's all kinds of skills and attributes that are true for any engineer, for any profession of any kind. And I'm going to summarize it down to just a couple of them. I think in the webinar notes, I pointed out a couple of papers that talk about a number of different elements and skills that we have or should have to be really good at what we do. And that's, of course, is just my opinion. But if I break it down to just three pieces, I would say is that we need to ask good questions. Years ago, I got invited to a meeting that was looking at a database and the database structure and the flow of information on a financial set of systems at Hewlett Packard. And other than my boss saying, yeah, you should go to that meeting, I really had no idea why I was there. It's not my field. It's not something I do. I don't work in finance. I don't work with databases. I wasn't conversant in that realm at all. And I was having trouble trying to figure out, well, where's the reliability part of this? I can understand the importance of the information, but what was it they were talking about? And so it turned out that part of the problem is that as data gets manipulated in different structures and different databases and different moves from one structure to another, errors start to creep in. And The obvious one is that input errors occur, but also calculations, manipulations, and rounding off, and all kinds of other things, and just errors. And they were looking at, well, how do we make the final data that we use to make decisions as true to the original and to what should have been put into the system. And the idea then of just asking a couple of questions to clarify what they were talking about certainly helped out a lot. And that's the program director then, thanked me for just asking a couple of questions. It was just being inquisitive, being interested in what it was and how does it impact reliability. Yeah, Naveen, I just saw your note. Let me pull that back up again real quick. And for should be seeing it pretty easily now. It should be downloads pod is on the right hand side in the middle there. And there's a couple of links for those that already have the slides down. There's some other links there that should be active. But one of the main things that we do, especially for answering the question of what will fail and when will it fail, is there's literally thousands of ways a product can fail. And so asking lots of questions of our vendors, of our design engineers, of our manufacturing engineers, asking questions from every failure that occurs, what was the information there? What happened that led to this event occurring? What are the consequences of that event? What are the ramifications of other similar events occurring? All of those things are just sets of questions that we bring to the table that is surprising how few other people actually ask. So part of our role as a reliability professional is really to ask the right questions. A lot can be said that that's also part of a role for lots of other people. But I think it's paramount to finding a lot of joy in reliability engineering is in how we ask the right question, which to a large extent is the biggest part of the challenge that we face. Because if we can answer the questions, whatever they are, then it relies on us asking the right questions. So part of it is just being curious. Why did this happen? What occurred there? The other part I found, and I found this one early in my career, is because of where we sit and work across an entire product line or product, is sometimes we have to bring together the software guy and the electrical guy in order for them to talk to each other to solve a larger problem, say a reliability performance problem. Or we bring together a mechanical engineer, industrial designer, and a software guy. I don't know if you've ever done this, is walked into a meeting and the different departments are basically blaming each other. Oh, it's a software problem. The electrical guy saying, well, it's a software problem. The software guys are saying, well, it's an electrical problem. And the electrical guys are saying, well, I can't do it because it's a mechanical clearance issue, blah, blah, blah. You can take on the role of saying, hey, look, we want a product that works for our customer over time. It's a reliability problem. Really don't care whose fault it is. What are the possible solutions? And so by simply reframing this in the context of reliability, it allows each of those three departments to get out of their own local priorities and look at the bigger picture. Now that's part of leadership. Now one of the links that's in the download is to the Association of Maintenance Professionals, and where there's a relatively new certification. I think it's been out for about a year, called the Certified Reliability Leader. And the premise is that anybody in the organization can be a reliability leader. I certainly believe that. And part of it is taking charge of the situation and helping the rest of the team understand and solve problems that improve reliability. And generally, the argument of saying this is the right thing for the business and it's the right thing for the customer tends to help a whole lot in that realm as performing as the leader. We're not just the guardians of one tool and reliability. We're talking for the long-term performance of the product in a lot of cases. And that inherently puts us in a leadership position. So when you see those opportunities, it's something that helps you and your organization. And one other part is, and the easiest way to frame this is when you look at your organization and you look at the types of testing that are going on, let's say there's a suite of environmental tests and different reliability type tests that occur. If nobody is using those, then what's the use? What's the point of spending all that money doing the testing? Years ago, I talked to a guy that was working on laptops, and I asked him if they were doing halt testing. It was one of the issues that it was apparent it was being done and not used. And he goes, "Oh yeah, we have to do it. It's a requirement." But they overstress the product, so they always break it. And so what? We know if you overstress it, it's going to break. And they're way above our operating limits. What that engineer was missing, though, is that those reports contained a bunch of nuggets that allowed them to make improvements on the product. He missed that connection of how that tool was to be used. So a little bit of retraining, a little bit of insight there allowed them to take the value out of doing that test. But if the test was ignored, then what's the point in even doing it? So in a larger context, whenever we're working with reliability in any of the tools, whether it's an FMEA or an environmental test, what's the point of the test? What question are we trying to answer? Who's going to make a decision based on that information? And is it the right thing to be doing at this time? Is it the most valuable thing I can be doing? And so one of the download links on one of the Ascendo reliability site ebooks is on finding value, which is a great touchstone to figure out, is this test worth doing? And if I'm proposing an accelerated life test, it may cost $100,000 in samples and test equipment to do. Is that the right investment? Do we really need to know that answer that precisely? All those kinds of questions come into it, is that we start to look for what's the cost benefit of the things that we do. And Shivan Shu, I'm sorry if I'm not pronouncing your name correctly, the CRA exam in the body of knowledge, and it's a good question. If you don't have background in reliability and you haven't worked in that field, then don't sit for the exam. That doesn't make sense. But the body of knowledge and the information there gives you an idea of the types of tools and the breadth of information that comes with learning reliability engineering. So it can provide a really nice background for what you need to know to be considered a reliability professional. So reviewing it and looking at the CRE prep site gives you an idea of the tools and techniques that are out there that allow us to contribute to the organization. And thanks, Gregory. I see the link to the Certified Reliability Leader certification, which is, I think, is pretty cool. I think it's a pretty neat exam. Yeah, Thomas, I agree. It's exercising it's a lot of reliability statistics to some extent, but exercising your knowledge in the preparation for the exam helps you become a better engineer. And I think that's where the real value is. It's not getting a certification suitable for framing. It's solving better problems, helping design and create better products, helping to maintain a line with a higher uptime. Those kinds of activities then lead to value, something you can quantify. But doing our job well, I mean, that's great. That's important. But how do you define success? And one of these other webinars, we talked about success, in that there was elements that were intrinsic. You feel good because you did a good job, the self-satisfaction, those kinds of things. And then there's also the external rewards of peer recognition or a bonus or things like that. So as you look at reliability engineering, keep in mind what's important. What's important to you, what's important to your organization, what's important to your peers, and to as much extent as possible, as you're adding value back to the organization, look for those things that help you be successful, however you define it. I know in my career that the being able to answer the question of how long this product will last, doing an accelerated test, that was personally gratifying. I enjoyed the combination of experimental science and statistics and in being able to answer that question. And then my management team using it to make decisions. That was cool. And that was helped me say, that was useful, that was valuable. I enjoyed that. And that was how I defined success. So I looked for more projects like that. And to a large extent, that's why I fell into um, being a reliability engineer. Naveen, the reliability implementation and carrying out reliability tests, those are two huge topics. And so I don't know if I put it in the links, but it's in the Ascendo reliability site, is an ebook on reliability maturity, which lays out a lot of a way to assess an organization and to say, well, what do we need to improve? Is it tools? Is it communications? Is it failure analysis techniques? Whatever technique it is. And so that's part of the question. The the reliability testing, again, that's a massive topic. There's everything from doing environmental tests, will it work in the environment that we expect to put it in, over to accelerated testing. So will it last 20 years without failure? Um, and right now on the Sendo site, I don't know that I have much up there. There are links in the download file that talks about the ReliaSoft site, um, the RIAC, Reliability Information Action Center, if I remember the acronym correctly, and a handful of others that provide a wealth of information that can help you answer those questions. So, Sivanshu, this is you asked what I define as a great question because it's really the next slide, next section. So, the direct way, and by way of full disclosure, is I teach at University of Maryland a course on reliability engineering management at a graduate level program. Um, there's this one of the links is to the reliabilitycalendar.org slash higher ed, I think is the short form of it, where it lists the reliability engineering programs that we found around the world. So from Beihang University in Beijing, which has a great reliability program, to Arizona, that's got a emerging reliability program in the aerospace industry, and Arizona State focuses on semiconductors. University of Maryland, University of Tennessee, both have excellent programs. The Maryland program tends to focus more on electronics and product design and the mechanical and electrical parts of new products, whereas Tennessee tends to focus more on maintenance and maintenance reliability engineering. Uh, the site reliabilitycalendar.org has, I think there's 12 or 15 different universities that we've identified, and this is with the help of uh, El-Assad. I'm sure I'm not pronouncing that correctly. He's a professor at Rutgers that also has a reliability program, and he's an author in reliability that has identified these programs from around the world that you may want to go get certifications or take offline classes or go back to school and get your master's or your PhD. Now, some students go straight from undergraduate into a reliability program. Um, that's not the path I'm familiar with, and I've known people that have been very successful doing that. And I've also known people that floundered because they just didn't have the the grounding of what a factory was about or what a product design team was about. They didn't have the practical experience, and it took them a while to build it, if they ever did. So there's a lot of schools out there, and there's also a lot of seminars and workshops and all kinds of other stuff available. So it doesn't have to be just back to a formal school. And so conferences like RAMS, the Reliability and Maintenance Symposium, I know that SMRP has a couple of big conferences. Uptime Magazine hosts, I think he has like 3 or 4 different conferences more focused on reliability maintenance and asset management. Um, there's literally hundreds of different conferences. Some are very specific, looking at just ESD, electrostatic discharge. Um, some conferences are very broad, like RAMS, that has, I think they have 4 or 5 tracks this year, and they talk about medical devices and solar panels and automobiles and military systems and um, electronics, all kinds of stuff gets talked about, but it's more of a focus on the tools and techniques we use. And the question about online learning, um, it's mixed. I think there's some really good stuff out there. Um, and, and one of the things that comes up online is just reading. I, on the reliabilitycalendar.org site, there's a section called reading. And I think there's 60, 65 reliability focused blogs that we've identified, and some are active, and some are very active, and some are, I think, have been discontinued, but hopefully they'll come back to read again or to writing again. But people have approached a lot of different topics on the various blogs that are out there, these short articles that are out there. But there's a recommended list of books, there's newsletters, email lists, all kinds of reading material. I think there's close to 200 different sources of reading about reliability engineering. Yeah, Naveen, yeah, reliabilitycalendar.org. So and that's where the conferences is also, the higher ed is up there also. On the homepage is a Google Calendar that lists seminars and workshops and meetings, conferences. If you click through, I think it's on the lower right-hand side, maybe lower left side, there's a link to see it on a web page, a Google site. And that allows you to do some more sophisticated searches. I've heard of people that used it to say, well, I want to go to a conference while I'm in Europe. What conferences are available at that time? Or I have accelerated life testing. Which conference should I go to? And it provides the background, the information of what's out there and what's available. Good question on colleges, universities provide online courses. Well over half of my students at University of Maryland are remote. And I know that they do their complete master's degree remote. I'm not sure about the PhD, if they can do that completely remote or not. But if you go to the reliabilitycalendar.org on higher education, we list the different programs there. So it's a mix of what they focus on, and there's contact information for each one of them of how they run their program. You can ask them those questions directly. I don't think all of them provide their entire program online. I know Maryland does, but I'm not sure about the other ones. It'd be worth looking at what you're interested in, and then ask the campus itself directly. And Orwell, yeah, the shout out to the webinars listing is on that page. We list the 15 or 20 reliability webinars that are offered each month. And there's a sign up list for a email list, so you can get the listing a few days before the start of the month of all of the different topics that we can find that are coming up in the next month. Or you can visit the site here where we post that same message. But if you'd like to join the almost 500 other people that are on that email list to get a monthly update of what's coming up in the next month. So you can take a short-term view of your professional development. But there's plenty of material available online, and reading are just two of the pieces of this. And then there's tons of websites that just contain tutorials and um, uh, background pieces. I mean, there's everything from Wikipedia, which some people love and some people don't care for, to a massive database of I would say tutorials, basically, and online textbooks, basically, at Reliasoft at their site called Weibel.com. I mentioned earlier RIAC. Um, I think they changed their name. They moved to a different organization. It's called theriac.org now, is their website still. And they've got all kinds of military documents and studies and research material that's there. They put together a website that's focused just on physics of failure. So it's listing all of these papers that provide models for different failure mechanisms for specific types of information, specific types of failure mechanisms. I believe the site's called WARP or WARP, but you can find it through theriac.org, and it's one of the links in the downloads. Between the reading site and the reliability calendar, we're trying to capture a lot of this kind of information, the stuff that's available for you. It never ceases to amaze me or surprise me that when something new comes up, and in our work, we get a question like, what's the life expectancy of fiber optics in an undersea cable application? Well, I have no idea, right? But I know where to go look. There's a handful of different sites and websites and searches that allow me to get really close to finding, well, how do fiber optic cables fail? And in that environment, somebody's probably written about it. And so between Google Scholar and a handful of other tools, we can find a lot of great information. Part of it's just practicing and knowing where to look. But there's also forums like LinkedIn groups and Google groups that are starting to develop in reliability. There's even one now on Facebook, a reliability engineering group that's just getting started. By far the best ones are in LinkedIn. There's Reliability Success. It's a bit more maintenance organized. It's a huge group and very active. The different professional societies have groups, and there's different industry-specific groups that talk about reliability aspects of their products. Those are all great places to ask questions of where do I find more information on, or has anybody studied this, or is this is the symptoms we're seeing, what's the appropriate way to do failure analysis? All of those kinds of questions can go out to hundreds of different of your peers, and you will find that by and large, this community is very supportive and will provide information back for you. So you're not alone, even though you might be the only, quote, reliability engineer in your organization. There's a few thousand of us out there that are willing to help you. And the online forums, the groups, basically, especially in LinkedIn, have been really, really helpful. And then the other part is the ongoing professional development. And back to these online courses. Last year I took a course through edx.org, and I don't think I put that link in the site. It's a massive online course type project. It's free, but it was taught by, this course I was taking was on statistics, basic statistics. It's something that we use all the time, but getting refreshed on hypothesis tests and confidence intervals and basic ways of looking at data was very, very helpful. And it was a 3-part course taught by a professor at Berkeley that she was very eloquent and very clear in how she presented it. So I learned a lot. it's still going back and learning that, and took the time to take the course. Courseira's got a bunch of courses. There's a series of courses I'm interested in taking. I just need to find the time on R. If you look at R, it's just the letter R, and I think it's CRAN, and I don't remember the site, but it's a reliability or a statistics programming language. And I've been using variations of it for years and years and years, yet there's so much to learn on it. And so I keep going back looking for courses and material on how to use this software package. It's an open source software package that's free. It works on Macs and PCs and Linux machines. There's a huge community that will help you master it and learn the tools and techniques of it. It's got a steep learning curve, but it's exceedingly powerful, and it's free. Just add time. Yeah, MIT is in EDX. I think they've got like 30 or 40 different universities represented now, and there's courses everything from um, anthropology to electrical engineering and everything in between. I tend to focus more on the statistics type stuff. I did take one on food science from the EDX group that was fascinating, but not for the home cook. Um, but it's ongoing, and that's where that reliabilitycalendar.org comes in handy. Is from the university programs that offer seminars and workshops to the webinars that come out every month and on a regular basis over a wide range of topics, to the online courses that are free, and just all of the reading materials that we can stay fresh and learn as we go and put this together. So I appreciate people typing in some of the websites and stuff. What have I missed though? What are your go-to sources for reliability engineering? AMSA. Carl, is that the heating? No, that's ASHRA is the one I'm thinking of. So, Carl, what is AMSAA? I'm not familiar with that one. Yeah, a lot of the reliability programs do teach statistics. It is a big part of reliability engineering in many regards. Um, I know Maryland has extensive classes on reliability statistics. I I don't have experience with the other ones. Yeah, Neil Behringer, excellent site. It takes a little bit of getting used to the navigation on that site and stuff, but he has a ton of great information. Army Materials Systems Analysis Activity. Ah, yeah, yeah, Carl, they have great information. Didn't recognize it. Uh, these these various military activities, from JPL to NASA, to the more military type based ones, have great information on guidelines, and the site that I go back to quite often is the Ministry of Defense in Great Britain for their military. It's where I first learned about reliability cases, which is, instead of just doing a suite of tests, is do a is create like a legal argument that says, here's the evidence that this product is reliable and to what extent. And it's a different approach than saying thou shalt do FMEA in these environmental tests. It says, prove to us that you know how it fails and when it will fail, and lay out the argument for it. The National Institute of Technology has the engineering statistics handbook. I probably use that every couple of days in one form or another. And then the reliability analytics toolkit. Uh, I'm trying to remember what site that's on, but I think if you search just for the analytics toolkit, you'll find where that is. I think that's Item Software, if I'm not mistaken, or it might be another vendor that provides that. But software vendors often provide a lot of background information about how to use their tools and what circumstances is. That's free available information. Allows you to go learn quite a bit. But, pardon me, my cat wants to join the argument, the discussion here. So, yeah, tons of resources out there. If you're having trouble finding something, that's where those LinkedIn groups, which are the more active ones, can help you find stuff. Or just send me a note. I'm glad to share with you what I know and where that stuff is, if I even know. So once you get all this information, right, once you want to learn about reliability, once you find this, which can be overwhelming amount of information is out there, then what do? Well, as I started the discussion, I was asked to find out how long something lasts. Here's our product, it's in design, will it last 20 years? And what I did is I started asking questions. Well, how does it fail? What's the mechanism for it? Well, how do we go into this? There's that inquisitive part. I went and talked um, uh, um, to chemists. I went and talked to the design teams and asked a bunch of questions. And I learned about how it would fail. Then I had to figure out how to compress that. So I learned about the Arrhenius equation. And so I took it one step at a time as I laid out this project of, well, how long will it last? And then learned how to do accelerated life testing. And with all of the resources and tools and our peers being available, you can lay out, here's what I think I need to do to solve this problem, and run it past a bunch of people and get their insights and advice and wisdom of how to best solve the problem you're facing. So that's one way to gain that knowledge. But now that you have this knowledge, now what do? Right? So it comes back to adding value, right? It doesn't do us a lot of good just to go run a test. Just go do an FMEA if it doesn't actually improve the product, if it doesn't add any difference to the organization. So part of this is, as we apply and use our skills, let's use them wisely. Let's use them to actually make a difference. So what I tend to do is ask, well, where's the decision going to be made in this with the results of what we're doing? Who needs this information in order to make better decisions? And that's the essence of adding value. Another thing we need to do is, especially when we're working on a particular project, is that we may need other things from within the organization that are more associated with the entire program. How do we get field returns? What are the tools and techniques and relationships to do failure analysis? Do we have an internal laboratory, or do we need to build one? Or do we have an agreement with a local laboratory? How do we put all of that together so that we can create a sustained program focused on improving reliability? And then the last thing is teach. One of the best ways to learn a subject and to master it is to go teach it. And that's everything from teaching at a university level to teaching one-on-one with your engineers. Teach them what you know about reliability engineering, about derating guidelines, about stress strength calculations, about the statistics that we use to make decisions, so that they can become reliability minded also. So the idea is that the culture that you create in your organization, to a large extent, is just converting everybody into a reliability professional. Now, if they just ask the right questions, and they may rely on you for the deep knowledge of some particular tools, that's fine. But it really starts with people asking the right question. Will this last long enough? Right? That's a key piece of it. And John, I just saw your note on, why did this fail? Yeah, if it goes to who's at fault, it's probably not healthy. If it goes to what can we learn from this, how do we avoid this in the future, how do we create a system or a process, a program that allows us to avoid making this mistake in the future, those are all good things. And that's where this teaching part really comes into play. Yeah. Naveen, good materials on reliability implementation. I would Yeah, I'll leave it open to the rest of the team here if people know where good stuff is, but we'll probably need a little bit more details of, well, what kind of program, what kind of product. I mean, can you get samples? Is it very low volume, expensive? Is it high volume, high risk? What kind of product is it? Um, and also send me an email directly, and maybe we can sort out where the best information I know is that could help you out a lot. That'd be great. So anyway, that's the presentation, and I'll leave this question up. Is really, how did you get started? And hopefully you saw some of that in the presentation today uh, that touched on different ways people get interested in it. But basically, it's we ask the right questions. At least I think they're the right questions. So as you progress in your reliability engineering career, what do you want to know? Do you want to master accelerated testing? Do you need to pick up a particular skill set for your organization, for your tools? And then break it down. Sort out what needs to be done. How do you get that skill set? So the resources like the reliabilitycalendar.org is one place to look for how to learn stuff, but there may be more detailed stuff within your organization. So work with your team and with your management team to figure out, well, how do we do failure analysis? How do we master the use of reliability goal setting, for example? Those kinds of things. And then get it started. Take a look at what works for you, what makes it successful, and how you define it, and have fun. It can be a really exciting career. Never cease. Plenty of opportunities to learn. That's continued all through my career, and it's the part that I enjoy quite significantly. So I'm taking a look at some of the notes here and stuff, and we'll wrap up here in just a moment. Let me pull up the conclusion slide. I think the chat window stays active there. Yeah, no, it's just on the left side. Sorry about that if you were typing. Um, so you can grab the webinar notes that have all the links. Um, the NIST book is the Engineering Statistics Handbook. And it has a good chapter on reliability. It needs some more tools put into it there, but it's got a good scope of that, good pieces of that. In the scope of reliability, um, that is massive. I mean, you can do just a specific tool, like just doing reliability predictions or just running a test. But keep in mind that that results of that process that you're using or that tool you're using has to make a decision and fit into the context of the larger organization that you're working in. So understanding the entire business and what drives making decisions and what's important, that expands the scope of reliability. So for me, reliability goes from concept to final retirement and recycling or whatever on the end of the life of the product. It goes through the entire design process in great depth and the supply chain and the suppliers and suppliers in some cases. It includes manufacturing. Um, I learned as a manufacturing engineer that we can only make it worse. And it goes on and on of the scope that you can get into with reliability. When I was at Hewlett Packard, I worked on individual specific tests for a new failure mechanism for a new component, and we also worked at the group level of $20 billion business and the senior managers there of how to approach the reliability program that they created and to improve it. So the scope was immense. It was really, really great. Um, scanning through this, some books is the best place I would go. Is the best book I recommend for reliability is a broad picture of it is the Practical Reliability Engineering by O'Connor and Kleiner, and that's in the reliabilitycalendar.org/books section. There should be a link to it there. It gives a really broad overview, or a lot of great tools, a lot of real practical stuff, hence its name. It's an excellent book. It's a little bit expensive. I think it's out in paperback now, so it's like $70 or $80, I think. But it's an excellent book. Yes, teaching certification classes is a great way to refresh your own skills. If you can explain it clearly to other people, that's a great way to cement that knowledge in your own mind. But it also, you can learn a lot from your students as to what questions they have and where they think that will come together. That would work too. Yeah, the Think Reliability group, they really have an interesting way of looking at root cause, and they take on all kinds of interesting cases as examples. And they do, I think, a webinar almost every week. And it's pretty neat stuff that they do. Let's see if I missed any questions. Naveen, process and procedures in a reliability lab. Well, for me, it really boils down to is what's the question you're trying to answer, and are you able to isolate the failure mechanisms? Are you looking to create models, to time to failure type models, or are you looking at more of the halt style of, well, where's the weaknesses, or possibly a mix of those things? And then it's, to a large extent, especially in the labs, is, well, where's your failure analysis? How are you identifying the root cause of the failures that you're seeing? But keep in mind that it really has to be back to who's making the decisions and what information do they need to make really good decisions. So those are bits and pieces of it. So I hopefully in this really quick webinar illustrated that there's tons of information out there. And whatever it is that's your motivation, it goes from being curious about reliability or being asked a question about reliability and then learning about it and then picking up those skills and techniques. The CRE and the SMRP or the CMRP provide a breadth of the tools and techniques that you need to be certified as a reliability engineer from those respective organizations. But that's not the end of the journey. Part of it is how do you work with organizations? How do you work with your teams so that the reliability-minded people that you work with make really good decisions and make your products better, make your production facilities better? That's what we're after, right? And as you get started, it's identify what it is you're interested in. Pick up the tools and techniques, whether it's a training course or a seminar or a webinar or a book, and try it, practice with it, adjust, keep learning. Rely on your peers. We're out here to help. There's a lot of us that are more than willing to answer questions and help you keep making progress. And find the spots that you really enjoy and have fun. And so that's the idea. That's how you get started in reliability engineering. There's no right path. So whichever path you take, it'll work out one way or the other. What I like about reliability is that it's so broad, so flexible. There's plenty of room to grow, plenty of room to learn, and you can have an immense impact on your products and organizations by using the skills and techniques that we have available. So that'd be a lot of fun. So with that, let me close off the recording. I'll stay online, and if there's any more chats and stuff, and I'll see if I can find a better answer for you, Naveen, on materials for reliability lab implementation. But kind of racking my brain here in the background. But anyway, thanks everyone for participating. I appreciate it. Next month I'm going to be a week early, given my travel schedule, so it'll be the first week in February, and then I'll be back to the second week. I believe for the rest of the year. I think I have one other one that's going to be off schedule. Plus, I have a bunch of other exciting stuff planned for the year, so do stay in touch. Look forward to seeing you again on the